Hello everyone and welcome to the class where today we will do correlation analysis. So today we are welcoming bivariate data analysis guys. So till now in this subject called numerical statistical method, we have studied only univariate data analysis. Till now we have studied only univariate data analysis. So univariate data analysis, what we have done till now. So when we say univariate means we focused on one variable and we did data analysis on that particular variable. So that we have done till now. We have in the statistics we studied about a measure of dispersion. I hope you remember measure of central tendency we did. Then we did a measure of dispersion. After that, we did measure of dispersion. So we did measure of central tendency. We did measure of dispersion. We did measure skewness. Those were basically univariate data analysis where we focused on one variable and we did analysis on that variable. We tried to understand the general behavior of that variable. So that we have done till now. Now it's time to study bivariate data analysis. It's time to study bivariate data analysis. And when we do bivariate data analysis, when we do bivariate data analysis in bivariate data analysis, we'll consider two variables. Okay, so here let the two variables are x and y. Okay, so I try to find the relation between the two variables. So that is what we called as bivariate data analysis, where we talk about two variables and we try to find some significant relation between the two variables. Okay, so whenever we do bivariate data analysis, whenever we are trying to do bivariate data analysis, that bivariate data analysis is basically studied under two heads. One is called correlation and another one is called regression. Whenever we are trying to study, whenever we are trying to do bivariate data analysis, we do in the term of two variables, like the physical quantity what we use to do this bivariate data analysis is basically based on the two variables. So here, what the tool what we use is either it is called as correlation or the tool is either called as regression. Okay, so when we talk about correlation, regression, what is correlation? What is regression? So correlation is basically when we say correlation, correlation is basically it is a relation between two independent variables. So the relation between two independent variable that we call as correlation. So the relation between two independent variables that we call as correlation. Okay, and regression basically means the relation between two variables. Okay, where one variable is dependent on other variable. So regression is basically finding the relation between two variables, finding the relation between two variables. Okay, where we have an independent variable, which where we have a dependent variable which is dependent on an independent variable. So regression, when we talk regression, it's a relation between two variables where one variable is dependent on another. Where one is dependent on another. Where one variable is dependent on another. This is we call as regression. The regression is also the relation between the two variables. But in the case of regression, the relationship what we're talking about here, one variable is dependent on the another. That we call as regression. Correlation means the relation between two variables where both the variables are independent in each other. That we call as correlation. Anyone, any question? So we are now dealing with bivariate data analysis. Okay. So now you need to understand here in correlation, the physical quantity which measures the correlation is called correlation coefficient. Okay. So please remember. So you understood that correlation is all about finding the relation between two variables, which we call as correlation. The next thing what we need to understand is the term called correlation coefficient. Next thing we need to understand the term called correlation coefficient. So correlation coefficient is basically the physical quantity which measures the correlation between the two variables. Okay, so the mathematical parameter which measures the correlation between two variables is called correlation coefficient. Normally we represent correlation coefficient with the symbol called R. So we use the symbol R. With the symbol R, we normally represent the correlation coefficient, where the value of R is between -1 to +1. If I'm finding the value of R, the value of R is from -1 to +1. So please remember what is correlation coefficient. The correlation coefficient is all about finding the relation between the two independent variables. Two independent variables means those variables which are independent in nature, means they don't have any relation with each other. So those variables we call as correlations. Okay, and whenever we try to find a correlation between two variables, the value what you get, the mathematical value what you get, that is called correlation coefficient, and that value is between -1 to +1. Okay, so this correlation between the two variables can be negative or it can be positive. You need to understand. So the correlation between the two variables, correlation between the two variables, correlation between the two variables. Okay, it can be positive correlation. It can be positive correlation. Positive correlation means for whom the R value is between 0 to 1. That is called positive correlation. So all such variables where the R value is between 0 to 1, that means they are having positive correlation. Then negative correlation, when we say negative correlation happens when the correlation coefficient between the two variable is between -1 to 0. Then they are said to have negative correlation. So you need to understand these parameters, guys. You need to understand what is correlation, what is regression. Correlation is a relation between two independent variables. Regression is a relationship between two variables where one variable is dependent on the other variable. Okay, like one variable dependent on other variable. Like suppose if you write this y is equal to 2 plus x. So here I put any value of x, I'll get the value of y. Okay, here I can put any value of x, I'll get the value of y. So here x is the independent variable and y is dependent variable, because whatever value of x you are putting, then on that basis you are finding the value of y. So y is the dependent variable here. So like you hope you understand. So the mathematical parameter which measures the correlation or correlation coefficient. Okay, and the correlation coefficient is having a value between -1 to +1. Correlation coefficient is having value between -1 to +1. Okay, so when we go ahead and understudy the correlation coefficient, okay, it can be positive, it can be negative. Positive means the two variable. If positive correlation means, what do positive correlation means? When they are going up at the same time. When they're going down at the same time. So there's a two positive correlation. Okay, suppose 50% of your money you put in Infosys, 50% of your money, okay, whatever money you have put in Infosys, 50% of your money you invested in TCS. Okay, 50% of money you invested in Infosys, 50% of money you invested in TCS. Okay, both are IT based company. Okay, both are IT based company. Imagine if the dollar value depreciate. Okay, so dollar value depreciate or Indian rupee appreciate, automatically you get lot of losses. Imagine if the dollar appreciate, rupee depreciate, you get profit. Okay, so if any US change some law, some H1 visa law or anything, minimum tax law for the Indian companies which are doing business with US, so automatically both companies will impacted that like the same way. So because both IT based companies, so Any laws related to IT, any news related to IT will impact them like the same way. So both will go up on the same way, both will go down like the same way. So they're said to have positive correlation. Positive correlation means the two variable which is going up with two variables which behave similarly. So they when they go up, they will go together. When they go down, they'll go down together. Like you talk about stock market, currency market. So currency represent the economy. Your currency represent your economy. So if your economy is doing good, automatically currency will do good. Your Indian rupee will do good. If Indian rupee will do good, automatically Indian stock market will do good. So I hope you understand positive correlation. Negative correlation means when one is going up, the another variable is going down. Negative correlation. Positive correlation. If you study well, you get good marks. Positive correlation. Negative correlation. The negative correlation can be the scenario when one variable is going up, the another variable is going down. One variable is going down, another variable is going down. They are said to have negative correlation. Negative correlation. So then we call such variable are having negative correlation where one variable is going up, the another variable is going down. Like you can compare the gold price with respect to stock market price. Normally, it is being seen historically that whenever the stock market is not doing well, then people will rush to alternate investment source, and that time they choose gold as a safe haven for their investment purpose. So you can understand. So definitely, if your stock market will do well, you will not see much momentum in the gold market. But if your stock market is not doing well, automatically you see a lot of momentum in the commodities market, like gold or silver or crude oil or anything. So you can understand this part. So the correlation between the two variable, it is between -1 to 0, sorry, -1 to +1. 0 to 1 means positive correlation. 0 to -1 means negative correlation. So whenever we find the correlation between the two variable, we'll get the value between 1 to +1. So the two variable can be positively correlated or they can be negatively correlation. Any doubt, anyone? So the formula, what you need to remember here for calculating the correlation, the methods of calculating correlation, the different methods are there to measure the correlation. There are different methods you have. You can study Carl Pearson correlation coefficient formula, correlation coefficient method. We can find correlation coefficient between the two variables by using Carl Pearson correlation coefficient method, or we can use Spearman rank correlation, Spearman rank correlation coefficient method. We can use Carl Pearson, we can use Spearman, then we can use scatter diagram. We can use bivariate frequency distribution, bivariate frequency distribution. We can use bivariate frequency distribution. We can use bivariate frequency distribution method. We can use bivariate frequency distribution method. We can use Carl Pearson, Spearman scatter diagram, bivariate frequency distribution method. Okay, and then we can use a concurrent deviation method. Concurrent deviation method. These are basic methods through which we can measure the correlation coefficient between the two variables. Anyone, any doubt, any question? So these are basically five methods to measure the correlation coefficient. So one by one, we'll try to study each method. Out of this, the most important is Carl Pearson. So in exam, if you get a numerical, you'll get numerical on Carl Pearson. After Carl Pearson, the next which is important is Spearman rank correlation coefficient. These two are very important. Clear everyone? So we'll do one by one all the method. So if I talk about Carl Pearson, if I talk about Carl Pearson correlation coefficient, if I talk about Carl Pearson correlation coefficient method, if I'm talking Carl Pearson correlation coefficient method, okay, there you need to remember this formula that the covariance between x and y is equal to R between x and y. R means correlation coefficient between x and y into standard deviation of x into standard deviation of y. So this is very important formula which you need to remember. Covariance between x and y is equal to R between x and y. What is R? R basically means coefficient of correlation between x and y. That we call as R. R is the correlation coefficient between the two variables. This sigma x is standard deviation of x. This is standard deviation of y. So R of xy is equal to correlation coefficient that is equal to correlation coefficient. R of xy is correlation coefficient between x and y, that is R of xy. This is standard deviation of x. And this is standard deviation of y. Covariance between x and y is equal to R of xy into standard deviation of x into standard deviation of y. Covariance is basically the risk. Covariance is basically the risk which come in picture whenever the two variables come together. So the mutual attraction repulsion will create a new kind of risk which we call as covariance. So guys, I must have believed that you are aware about variance. What is variance? What is variance? Variance is the risk contained in one variable. The risk which is contained in a variable that we call it a variance. Okay. So you studied variance, standard deviation, and all. So the risk pertaining to one variable that we variance. Okay. The square root of that is we call the standard deviation. You know that, right? Covariance basically means that when we are studying bivariate data analysis, here we are analyzing everything in the term of two variables. So when we say covariance, covariance basically means the mutual attraction repulsion a risk which arise when you bring two variables together. So then that kind of risk we call it covariance. What happens actually that when you bring two variables or when you put your money into stock. So earlier you were putting your money in one stock only. 100% of money you put in one stock. Now instead of doing investment in one stock, suppose you thought to follow diversification or to create a portfolio. So 50% of money suppose you put in stock one and 50% of money you put in stock two. So what actually happened, because the moment you reduce your percentage of your investment in each individual stock, automatically you can understand the variance of each stock will decrease. Okay, because when you say the now we have done investment in both the stock, so 50% in stock A, 50% stock B. Now, when we look into this parameter, you can easily understand that because you are doing investment half in two avenues, automatically the variance of each avenue will decrease as compared to if you would have done investment 100% on one avenue. But what actually happened, although the variance of two variable got decreased because you have done less investment instead of 100% investment, but what happens along with the variance when you bring two variables together, a new forms of a risk will emerge, which we call a covariance. Okay, so that is what you need to remember here. So, so now one by one, I'll write down the formula. If possible, please write down the formulas. So when we say covariance, so you know the formulas. Covariance basically emerge when you have more than two variable together. So when you have more than two variable together, so then you have covariance. You know the formula that variance of x is equal to sum of x square by n minus x bar square. This is the formula you know. Now covariance between x and y, that is basically sum of xy by n minus x bar into y. This is covariance between x and y. And this is the covariance between x and y. X covariance, the term covariance come in picture when we say covariance. The term covariance come in picture whenever you have two variables. Okay, this is one formula. This way you can understand. The other way, you know the formula of variance of x is equal to summation of x minus x bar whole square by n. Similarly, the covariance between x and y is equal to summation of x minus x bar into y minus y bar divided by n. I hope you can easily understand. It's like same only. When we talk about here, we are talking about the variables in this form x and y. We are not talking about only one variable. Whenever we are studying a measure of this of bivariate dispersion, so all our analysis, the data what we are talking about, we talk about the data in two variables. Is this part clear? So standard deviation of x, variance of x formula, then how we can write the same thing, the covariance in the term standard deviation or in the term variance. I think everyone understood. Anyone any doubt? So this is the formula of covariance, guys. You know the formula standard deviation very well. I just now told you the relation. I just now told you the relation. Please remember the relation that covariance between x and y is equal to r. R matlab coefficient of correlation. Coefficient of correlation between x and y into standard deviation of x into standard deviation of y. Okay, so I can write, guys, I can write r. R matlab coefficient of correlation. So the coefficient of correlation between the two variable is equal to covariance between x and y divided by standard deviation of x into standard deviation of y. This is the relation between the R covariance and standard deviation. Remember this. Anywhere, any doubt? This actually helped me to derive the formula. Is the formula of R. So I'll use two methods to find the value of R. Method 1, or I can use another method, method 2, to find the value of R. I can use two methods to find the value of r. I can write r of xy. You know that that is equal to covariance between xy divided by standard deviation of x into standard deviation of y. So you can write the same thing here also. R of xy is equal to covariance between x and y divided by standard deviation of x into standard deviation of y. Okay. Then you can write R of xy is equal to covariance between x and y. You can use one formula 1 by n summation of x minus x bar into y minus y bar. Okay, this is one way. This is covariance divided with standard deviation summation of x minus x bar whole square by n into summation of y minus y bar whole square by n. Okay, so r of xy is equal r of xy. Here you can write. Okay, here you can write 1 by n summation of x by n minus this. You can write another formula. This means sum of xy by n minus x bar y bar divided by standard deviation sum of x square by n minus x bar square sum of x square by n by x bar square or you can write this is equal to this is sum of y square by n minus y bar square. So I hope you are understanding this. I'm simply writing the same thing. I'm simply deriving. I hope you understand. I'm deriving the formula of correlation coefficient through Carl Pearson correlation coefficient method. So you know the relation that the covariance between x and y is equal to r of xy standard deviation of x into standard deviation of y. So you can write r of xy is equal to covariance between x and y divided by standard deviation of x into standard deviation of y. So in place of covariance, you can write this formula of covariance. This is the formula of covariance. So these are the formula of covariance. You can write covariance is equal to summation of x minus x bar into y minus y by n, and or you can write this formula of covariance that sum of x y by n minus x bar y bar. Okay, so this if you divide by the standard deviations, okay, this if you divide by the standard deviation, what you will get? You will get the r value. So if you divide by standard deviation, you get the r value. So r is equal to 1 by n summation of x minus x bar into y minus y bar. This divide by under root of summation of x minus x bar whole square into summation of y minus y bar whole square by n square. Okay, now you can write this formula r of xy is equal to summation of xy minus x n x bar into y bar, or you can write here this is summation of xy by n. This x bar you can write x bar you can write sum of x by n into this y bar you can write sum of y by n, this whole divided by under root of summation of x square by n minus summation of x का whole square by n square. Okay, and then this is summation of y square by n minus summation of y का whole square by n square. Clear? Anyone, any doubt? So now what I can do, I can write the value of r. So if I bring outside r of xy, 1 by n divide by 1 by n, this is summation of x minus x bar into y minus y bar. This is under root summation of x minus x bar whole square into summation of y minus y bar whole square. 1 by n I can cancel. So this will be equal to this I can write as summation of xy by n minus sum of x sum of y by n square. Okay, so the same thing I can write here in denominator also. The same thing I can do. You can take LCM also. This will be n sum of xy minus sum of x into sum of y by n square. This you can write this as n sum of x square minus summation of x whole square then we can write the same thing for this n summation of y square minus summation of y whole square. By this here you get n square, here you get n square. Any doubt, anyone? So if you understand, then you can write the same thing. R of xy is equal to n summation of xy minus summation of x into summation of y divide by n summation of x square minus summation of x का whole square into n summation of y square minus summation of y का whole square. And then will get cancelled. So this is n square under root n square under root n square, that is n to the power 4. If you bring it outside, that become 1 by n square. Both will get cancelled. So this is one formula of r of xy. Anyone, any doubt? So guys, you just need to remember this. You don't need to remember the derivation, guys. You don't have to remember the derivation. Remember this. This is more than enough. Remember this. This is more than enough. This is more than enough. Okay. I'm just showing you the steps of getting the answer. I doesn't mean that you have to remember the steps also. Okay, everyone. So here you can write the same thing for the R. Another formula of R. The another formula of R is equal to summation of x minus x bar into y minus y bar divided by under root of summation of x minus x bar whole square summation of y minus y bar whole square. This is another formula of R. So these are the two formulas of R of xy. Okay, everyone. So many books and all this is also written like this. This is also written R of xy is equal to summation of dx dy divided by under root of dx square into summation of dy square. Where in many books and all they write dx means x minus x bar, dx means x minus x bar, and dy means y minus y bar, and dx dy is equal to sum of dx dy is equal to sum of x minus x bar into y minus y bar. Numerical based on this formula we'll do tomorrow. For the time for today, you just write down these formulas. So in many textbooks and all, you write like this. So please understand. Any numericals, if it comes, we'll use this formula to get the answer. This way to find the R. This is called Carl Pearson coefficient of correlation method. R value, what we'll calculate, that will be between -1 to +1. Okay, please remember, if your R is negative, means the two variables are negatively correlated. One is going up, the another one is going down, and vice versa. While if the R is positive, means both will go up together, both will go down together. Anyone, any question? Now, some numerical, 2 marks numerical and all. Suppose if I ask you the coefficient of correlation between x and y is 0.48. Okay, the covariance between x and y is, suppose if I give you, is 36. Okay, so if the variance of x is equal to 16, the variance of x equal to 16, then find the standard deviation of y. Find the standard deviation of y. This question, everyone. Everyone, please try this problem. Now here the relation, what you know about them. Here the relation, what you know about them, that covariance between x and y is equal to R of xy into standard deviation of x into standard deviation of y. Now the covariance between x and y is given 36, R is given 0.48, the standard deviation of x, the variance of x is 16, So the standard deviation of x will be root 16 into standard deviation of y. So this is 36. I can write is equal to, I can write this 48 by 100. Root 16 means 4 into standard deviation of y. So this is 12 threes are, this is 12 fours are. Okay, so I can write 3 is equal to 16 by 100 into standard deviation of y. Standard deviation of y is equal to 300 by 16 is equal to 75 by 4. Standard deviation 75 by 4. So you can find the value, you will get 80.75. I'm not. See this, ask me, anyone have any doubt? Anyone, any doubt? 18.75. Okay, everyone. Anyone, any doubt, any question? So remember the formula. So the very important formula, guys. What you need to remember, guys, very important the formula that the covariance between x and y is equal to R मतलब coefficient of correlation between x and y into standard deviation of x into standard deviation of y. This is the one formula you have to remember. Next, the next formula of R, you can use any formula in exam. When you get the question, you can solve the question by any formula. N summation of xy minus summation of x into summation of y divided by under root of n summation of x square minus summation of x ka whole square into n summation of y square minus summation of y whole square. This is the one formula of R value. This is one formula of R, and as per the Carl Pearson coefficient of correlation. The another formula of another formula of R is summation of x minus x bar into y minus y bar divided by under root of summation of x minus x bar whole square into summation of y minus y bar whole square. This is another form. Remember this, guys. Remember these formulas, guys. Based on these formulas, we'll solve the problem. Tomorrow we'll start solving the problem. Today we just discussed what is R, how we get the R, what are the derivation of getting the R. All that we understood today. Anyone, any question, any doubt before I'll wind up the today class? Anything you want to ask from me? Anyone, any question? Okay, everyone. Then I'll wind up the class. Thank you, everyone. I'll see you all tomorrow.